This assignment is this case study is on logistic regression, basically HR analytics case study. This case study is tries to explain the business understanding here is that this XYZ company wants to prevent attrition, so it wants what are the possible factors that are influencing the attrition. It wants to understand that. For that, they were approached a consultant to understand what are the possible factors. So here, as a consultant, we received the data set from the company. The number of employees are somewhere around these companies have got 4,000 employees. Now here, the approach is Crispdium framework where we understood the business, what are the possible factors that are going to impact it, and also we have data understanding. And hence, for our analysis, we used RStudio and we go ahead with the data cleansing and data preparation, wherein we removed all NAs or we removed all inconsistencies in the data. We have seen we had to match some of the data sets here, example login logout data with each employee. We went ahead and did it. And coming to the exploratory data analysis, when we conducted exploratory data analysis, what we found out was somewhere around 16.2% is the overall attrition of the company. And here, when we were doing univariate and segmented univariate and bivariate analysis, we found out that better satisfaction, job satisfaction, work-life balance, reduce attrition, which is in line with our expectations. And year at company and total working years negatively impact attrition. And single status tend to be more attrition, and HR department has got out of all departments, HR has got highest attrition. And employee travel frequently are prone to attrition because if they travel more, they are going to be attrition is more. That's what it says from the data. Higher at the average working averages, which is propels higher attrition. That's what that is the recommendations that we initial insights that we got from uh, this exploratory analysis, and then we went ahead with the standard process, which is training and testing, dividing the training and testing data. Now we working on training the data using step IC. It's a normal process, like step IC will prune some of the variables, and we go and set up with VIF various influence factor which determines multiplicity. We remove those variables which have got highest VIF and low significance, high significance level. We removed the high means greater than 0.05. If we remove high VIF with greater than 0.05, remove the variables and check the multicollinearity like this, and we ended up with very low significant variables with all three stars where it is less than 0.0001. And once that is done, we tested the same thing on the test set. And here we need to look into the sensitivity and the specificity of the data, and we need to determine the cutoff. And how do we determine the cutoff level is the point where sensitivity and specificity will meet it. Now for some of the variables, sensitivity and specificity are very important. For example, let's say loan debt defaults. In loan default, basically the sensitivity could be 99%, but the specificity is 40%. It is not acceptable because here the loan defaults would be very less, and our model should be able to get those no's as well. So sensitivity talks about true positives rate, and negative specificity talks about true negative rate. So these two will be very close to one in each other, and it is preferably above 70 to 75%, or more than that would be uh, uh, very much preferred. And how upon this we need to look into the discriminatory power of the model, where we look into the gain and lift chart. Gain chart is how much of the how much of the variables that are falling, or how many number of variables that are falling in the first four deciles, or how we need to look into here. In this case, we have seen 80% of the attrition is captured by the first four deciles, so the model is doing pretty good. And the lift chart is somewhere around the index is 5, so it is very slant. So 80% of our model is two times better than our random model. So at 80% of our model, the two times better than the random model. So this is a pretty good model. So considering the variables, we have come up with some of the variables wherein years at company, number of companies worked, years since last promotion, travel frequency, age, marital stress, etc. will be highly influenced. So we have given them the recommendations as well, saying that the variables higher the job role, lower the attrition. So need to focus upon improving the job environment and job satisfaction level and work-life balance of an entry in the middle level employees. And also here the HR we need to study look into R&D department which have a low attrition rate. So we recommended all the company to look into their practices and learn from them. And ROC curve also says, how better it is considered to an average. So it should be more than 0.5 and it will always be less than 50%. The area under ROC curve is our gain, which we talk about. So it should ideally be more than 50% and it should go up to 1. But on 1 is ideal case wherein it will vary between 0.7 to 0.95, which is very good uh, case in this. So here, that's it from this assignment. Thanks for the time.